Good morning, everybody. Happy Thursday. We're at the end of the unit for relations and functions. Today is going to be a review video, and then you'll have today, tomorrow, the whole long weekend to get the summative assessment done, which is like our unit exam. So it'll be 20 questions on Google Forms, and yeah, you have the whole weekend to do it. So for studying, what I'm going to do is I'm going to jump into the workbook, and we're going to do the practice test in the workbook. Some of the questions are not so great, so we're going to skip those. And then I'll be posting a review package for you guys to do, similar to last unit, right? Maybe you can print it off. Probably not worth printing off. Just copy down the questions that you need, show your work, and get the practice that you need. So realistically, once you are done studying, you can get that summative assessment done. Okay. My kind of guideline would be study today, write the summative assessment tomorrow on Friday. I think that'd be good timing wise, but whatever fits you, right? If you need to take a little bit more, if you go into the weekend, that's totally fine by me. And it is the long weekend, so it won't be due till Monday at midnight. So that's it. That's our unit, and then we're jumping into the next one. So let's get this review lesson done, and we'll get on to some studying. Here it is, page 489. And this is the practice test for the unit. So yeah, I'm going to run through this. It's a decent review lesson. I'll hit some of the key concepts, and then you can really focus yourself in your studying with the review package that I'm posting as well. So some of these I'm skipping because they're bad and I've got them crossed off, but we'll just kind of work through. Okay, which of the following variables is discrete? Okay, well, discrete and continuous variables, that was one of the first things we looked at. Discrete variables were things where it's just whole numbers. There can be one of them or two of them or three of them, but I couldn't have decimals. Whereas continuous, that was every single value. Okay, so it was the difference between a dotted line and a connected line. Well, time taken to run 50 meters. Time could have decimals, right? You can have seconds, milliseconds, nanoseconds, whatever. It's not the distance traveled by a train, same thing. I could have kilometers. I could have meters, I could have centimeters, whatever, millimeters. I could get as specific as possible. I can have every single value. The number of animals in a zoo, to me, that sounds discrete. You have, you can't have half an animal. You have to have a specific amount. The weight of a dog, that would be continuous, so I know my answer is C. Okay, 2. Which of the following statements is false? The domain of a relation is associated with values of the independent variable. The dependent variable is represented by the first coordinate of an ordered pair. The inputs of a relation are shown on the horizontal axis of a Cartesian plane. The range of a relation is represented on the vertical axis of the graph of the relation. Pretty wordy. So what I'm going to do is one by one, and I'll make an assessment on each of them. So the first one, the domain of a relation is associated with the values of the independent variable. Well, the domain, that represents my input, my independent variable. Those also represent input. So that's true, which means it's not my answer. Okay. The dependent variable is represented in the first coordinate of an ordered pair. Well, I remember it always goes x comma y. So x is first, but x is my input or my independent. And this is saying the opposite. So B, that's actually my answer. That's the false statement. Let's check if the others are correct. The inputs are shown on the horizontal axis. Yeah, that's true. Not my answer. The range of a relation is represented on the vertical. Yeah, that's true. Not my answer. All right, great. Moving on, numerical response number 1. To the nearest hundredth, the positive x-intercept on the graph of the relation. This is, okay, well, I'll figure out my answer. I could use my graphing calculator if this said y equals, but it doesn't, so I need another method. But what I remember, an x-intercept happens when y is equal to 0, right? I haven't gone up or down at all. I'm just on that x-axis. So I take my equation, no matter what it looks like, I can always solve for an x or y-intercept algebraically. X-intercept happens when y equals 0, y-intercept happens when x is 0. I can always solve these. So I say, okay, well, 2x squared plus 6 times 0 squared equals 7. I plug in that y value that I know, and then I could solve the rest. And what I'd start by saying is, well, 0 squared is 0, times 6 is still 0. So it's 2x squared plus 0, or really I would probably just say 2x squared. Okay? And then I'd say, okay, well, I need to start solving for x. And I'd divide by 2, and I'd divide by 2, and you'd get x squared equals, let's just do a decimal, 3.5. And then you'd say, okay, get rid of the squared. And here's where we have to be very careful, because I remember if I introduce my own square root, there would be the positive and the negative version. X equals plus or minus the square root of 3.5. Second square root 3.5. So it could be positive 1.87 or it could be negative 1.87. This specific question, it only asks for the positive one, 1.87. But I know there are two roots to that thing. I know there are actually two solutions. Okay, next question, bottom of the page. What else are we looking at? Which of the following statements is true? Okay. Domains are same, ranges are different. Ranges are same. Okay, so it's all about domain and range. Maybe they're the same, maybe they're different. Okay. Well, what I'm going to look at is general ideas about them. So I'm going to look at the first graph and I'm going to say, for domain, it's kind of from this point and out, right? My domain would be x such that x is, well, it's bigger than that point, so greater than or equal to that point, but then my arrows go on and on forever. So let's just call that, I don't know, 5. Okay, I'm just picking something just for a reference. X element of the real. If I needed to state the domain, it would actually give me a value. Here I'm just comparing. And the range of that thing, y such that y is an element of the real, because my arrows go up and down forever. My y values go up and they go down diagonally forever and ever. Okay. Go over to the other one. Domain, x such that x element of the real. Here's the opposite. My arrows go up and over in both directions. So I'm never going to get any limit on my domain. So here I can actually cross off a couple answers. A and C are no longer answers because the domains are not the same. Okay. The domains are different. Okay. In terms of range, well, it's y such that, and I actually have that border as well. It's something and then going up. It's y greater than a certain point. Well, already, the first graph had YER. This one is different, so that means my ranges are different and my domain is different. D is my answer. Okay? So knowing these values is not important. Knowing that this one there is a restriction, this one there isn't. Range has a restriction over here it doesn't. Okay? That's what I have to look at. Domain and range. There's a lot of good domain and range questions in your review package that would be worth spending some time looking at. Okay. Skipping this question. Don't like it, don't want to do it. Let's go over here. Use the following information to answer the next 2 questions. Okay. We're only doing one. I crossed the other one off. I didn't like it. The cost of publishing a school newspaper is partially fixed and partially depends on the number of newspapers printed. The cost is given by this formula. Okay, cost equals 98 plus 0.12n. Great. The cost of publishing 780 newspapers is. So this is a great question. I could give it to you with an equation. A lot of times I'll give it to you with a graph and I'll say, hey, here's one of the values. Tell me the corresponding value. Okay. Well, 780 newspapers, that's n. So I'm going to plug that right in. C equals 98 plus 0.12 times your n value. You printed 780 papers. So this would be 98 plus, pull out the calculator, 0.12 times 780, 93.6. And then I'll add these numbers together. I get 191.6. That's what my calculator says. When I go to look at my answers, I notice that it's 191.60. Oh yeah, because it's money, and money would always go to 2 decimal points. Okay, so if I ever give you the input, plug it into the equation, and you'll find your output. Okay, it's as simple as that. 3, we're skipping. 5. F of x equals 3 minus 2x squared. That's a function. Okay, it has a domain, -6, -4, 0, 2, 5. Which of the following is an element of the range of the function? Well, my domain is all of my inputs. I have 1, 2, 3, 4, I have 5 inputs. And my range would be, okay, well, what do you get when you actually plug these in? So that's what I'm going to do. And because it's multiple choice, I'm really going to rely on my calculator. So I'm going to go 3 minus 2 times -6 bracket squared. Then I get -69. There's the first thing. Now let's do the next one. 3 minus 2 times -4 squared. And I'm just typing these into my calculator to see what the outputs are. -29. Hey, that's an element in my range. I think D is the answer. Plug in a 0. 3 minus 2 times 0. You get 3. Plug in a 2. 3 minus 2 times 2 squared. Good. I get -5. Okay. And plug in a 5. 3 minus 2 times 5 squared. -47. Great. Those are all my outputs. Those are all of the elements of the range. Yeah, well, I already actually found my answer. It's -29. Okay, so given the inputs or given the domain, I can plug in to find my range. Moving on. Number 6. It says the diagram shows the function y equals f of x. Okay, great. The diagram shows a graph. Yeah, it said it again. Okay. The value of f at -2 plus f at 2 is. Well, what this means is I got to go to my function and find f of -2, go to the function, find f of 2, and then I'll add those values together. Okay, those are inputs. So f at -2 means I go along the x-axis till an input of -2. Oh, and my point is actually 0. Okay, it's right there. Whereas f of 2, I go along the x-axis to 2. And you say, okay, well, what point has this actual input value? And it's down here, it's -4. So I've got 0 plus -4. Well, that would equal -4. A is my answer. So with the function notation, we just looked at this the other day. It's, same as me telling you the x value, find the y. Find the x, give the x, find the y. Okay? Same thing, it's just another way to write it. Consider this function. Okay, we're going to answer 2 questions. Okay, with function notation and with any equation, I could give you the input and ask for the output, or I could give you the output and ask for the input. So the value of p at 6. I am telling you an input. I am telling you wherever there was an x, now you replace that with the 6. So you plug it in, and you say p of 6 equals, well, that would be 30 plus 2, or 32. Hey, there's my answer C. The other option is, okay, what if I gave you the output? It's saying, hey, p of something is equal to 6. What was that something? So in this case, what it's giving me is p of x. It gave me the output, so I replaced the p of x. They call it p of b, but it's the same thing, with 6, and now I solve algebraically. I would say subtract 2 from both sides. You get 4 equals 5x. Divide by 5, divide by 5, and I'm going to get a fraction or a decimal. 4/5 equals x. And, oh yeah, they left it as a fraction for my answer. So those are the 2 things, right? When I give you function notation, or even just when I give you an equation, maybe I give you the input and I need you to just plug in and solve. or maybe I give you the output and I need you to go back algebraically and find it. Okay, moving on to the next page, number 9. Which of the following questions shows a relation which is not a function? Okay, well, the idea of a function was for my input, it spits out exactly one output, right? I cannot have an input that's indecisive, okay, that doesn't know. It has to be, put the input in, gives me one answer, okay, gives me one output. Or when I have a graph, it has to pass the vertical line test. There can never be 2 points with the same x value, 2 points on top of each other. So I pass through vertical lines, A is good. There's never a moment where a vertical line can hit 2 points. Same thing with B. And then you get to C. Oh yeah, that is definitely not a function. D is, it passes. But C, these 2 points are right on top of each other. They have the same x value. So that thing is not a function. It fails the vertical line test. 10. Consider the graph of the function f of x equals 4x minus 10. The x-intercept of the graph is... Well, here's where maybe I use my graphing calculator. Maybe I type that in real quick and find it. Or, to be honest, I would probably solve algebraically. Okay, we already did one algebraically. The x-intercept happens when y is equal to 0. Well, in this case, it's not y, it's f of x equals 0. But it's the same thing. Okay, make that 0, 4x minus 10, and I need to solve algebraically. Add 10 to both sides. You get 10 equals 4x. Running out of space. Divide by 4, divide by 4. 10 divided by 4 is 2.5 decimal. Hey, there you go. There's your solution. So, yeah, I don't care that it's written in function notation. It's the same as if it was just y's. Okay, it's no different. Moving on. 11, 12 bad questions. 13 bad question. Let's skip it. 14 bad, bad, bad. All right. Oh, yeah, we're almost at the end here. Okay. More of a theory question. Which of the following cannot be used to represent a function? Okay. Cannot be used to represent a function. A graph. Okay, that's one option. Table of values, ordered pairs, or a coordinate. Okay, well, a graph can definitely be used, right? Yeah, we've seen that all the time. Most graphs we look at are functions. Table of values, yeah, as long as I have all of my inputs are unique, good. Bunch of ordered pairs, yeah, good. Coordinate, well, I don't even really know what they're saying by coordinate. Maybe it means coordinates or ordered pairs, but I already said ordered pairs, so I know A, B, and C are good. Well, I guess I shouldn't have crossed it off. I should have circled it. So D is my answer. Coordinate doesn't really mean anything. It doesn't really make sense. The other three I know can represent functions, so that's my answer. Okay, let's go to the final question. And yeah, written response. That's the last one we'll do. It's the last question, and we're going to do this with our calculator. Okay, we're going to do everything we can with a calculator. So it says, during an air show, the path of a stunt dive of a jet can be modeled by the equation h equals t squared minus 9t plus 81, where h is the height in meters after t seconds. The end of the stunt occurs when the plane achieves its starting height. Okay. And then it asks a bunch of questions. How high? Blah, 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 blah. Well, let's graph it first, and then we'll go question by question. Go to my calculator. Go to y equals, the only place I can enter an equation, and I clear everything out. Oops. And now I'll type it in. It's t's, but I know I can do x's. X squared minus 9x plus 81. And I'm going to go zoom 6, zoom standard. Negative 10 to 10, negative 10 to 10. Right? This is negative 10, this is 10. Negative 10, 10. And, well, I don't see anything. Okay, so I'm kind of hopeless. So what I'm going to do is I'm going to just zoom out, right? I'll go to my window and, I don't know, let's just try going from negative 20 to 20. And negative 20 to 20. And I graph. Nothing. So I'm hoping to find something. I'm hoping to find a region. And this is going to be one of the hardest things. Well, here's another feature that I don't even think we've showed yet. We can actually zoom out without doing it manually. So I go to the zoom button. And the third option is out. So you can just press 3, or you can scroll down, hit enter. And then I need to pick the point I want to zoom out from. So it's kind of where are you centered and zooming out from. I want the origin, 0, 0. So I hit enter. Okay. Then it zoomed me way out, right? I can go to my window now. It says, oh, you're negative 80 to 80 now. And I can actually see a bit of the graph. So what I'm going to do is focus on getting this region. I'm not going to change my Y max at all, but I'll get rid of the Y min. I'm going to get rid of the X min. I don't need this space over here. And then I'm just going to chop. Okay, I'm going to chop my X's a little bit. So let's go and do that. Let's see. X minimum, let's go negative 1. Okay, and I'm going to change my scale to 5 because right now I have 80 ticks. I had a tick every 1. Let's change that to a tick every 5. Y min, get rid of it, just negative 1. Change the scale as well. And, I was going to change my X max. Let's go to half of that. Let's go to 40. Okay, pretty good. Okay, a lot better. I could probably reduce my X max again. I could just go to 20. Okay, great. Maybe even less, maybe 15. Okay, that's pretty great. And what I'm going to do is I'm going to go a bit higher on my graph just so I can see a bit more of the top of this curve. So instead of going to 80, why don't we just go to 100? Sounds like a pretty clean number. Awesome. I think that's great. Okay, I think that's really, really good. So we can see the starting point, 0 time has passed. This is the starting height. As time passes, the jet goes down, and then it swoops back up. And then we said the end of the stunt is kind of when this has the same point. Okay, so we'll probably deal with that. How high is the jet at the start of the dive? Well, that's this point right here. That's T of 0 or X of 0. That's asking me to find the Y-intercept. The Y-intercept happens when X is 0. I can enter that value. Second calc, value, X of 0. Boom, it jumps to that point. Y is equal to 81. Well, I'll call it H over here. H equals 81 meters. Okay, that's great. Okay, that was, again, second calc value. And my value is 0. Now it says, how high is the jet above ground level at its lowest point? Well, that's asking me this point down at the bottom. That's the minimum value. It's asking me the minimum dip. Okay, well, second calc is normally where I go. Oh, the third option is minimum. Hit that one. It says left bound. Are you to the left of the minimum? Here's my minimum. Here's the vertical line where the minimum occurs. Yeah, I'm to the left of it. I'll move a little bit closer maybe. Enter. Now are you to the right? Okay, well, I need to move to the other side of that minimum. Go to the minimum, move past it. That's probably good. Enter. And then make a guess. And it doesn't need to be a perfect guess, but it needs to be close. Okay, 4.5000032 and 60.75. This is, I think we talked about this in one of the lessons. My calculator's not always great. It means 4.5. Okay, if I try that again, second calc, minimum, move to the left a bit, move to the right a bit, and make a guess, 4.4999999, right? My calculator's not perfect. What I can see, the height is 60.75. That's my minimum height, okay? And then it asks, when does it reach that? 4.4999999. Okay, I bet if you did it on your calculator, you maybe got that. You maybe got the first thing. Let's try one more time. Minimum. Left bound. Hoping for perfect 4.5. Right bound and make my guess. Whatever. Okay, so this is where we have to be smarter than our calculator. I will never give you that number that's 4.500007 or 4.4999999. it's 4.5. That's what it means. Okay, t equals 4.5 seconds. And I bet if you tried again on your calculator, you might get perfectly 4.5. Okay, a couple more questions. How high is the jet 2 seconds into the dive? So that's saying if t equals 2, what is your height? Well, it's just asking me to put a value in. Okay, it's just asking me to put a value, second calc value. In this case, it's 2, a value of 2. And that would be a height of, what does it say? 67 meters. Okay, I can enter any value I want. And then it says, after how many seconds does this height occur again within the jet's stunt dive? So in this one, it's saying, hey, your height is 67. And I'm going to talk about the time, right? It's actually giving me the h value, or in this case, the y value. And I know there's only one place to enter y. And that's the y equals button. So I go over there, go to the y2, 67, and back to my graph. There's the first point, okay, 2 comma 67. I want to know this one. I want to find this one. So second calc, pretty much where everything is. Intersect, 5. Are you on the first curve? Okay, I'm on the blue one. I'm on the curved one. Yep. Are you in the second curve? Okay, yeah, now I'm on the horizontal one, the red one. Yep. And then make a guess and make sure it's close to the one you actually care about. And it says 7 comma 67. So maybe I would say t equals 7 seconds. And I'm on my way. Okay, so it occurs at 2 seconds. And it also occurs at 7 seconds. Okay. And that's it. Okay. That is using my graphing calculator. That's pretty much all I would ever ask you to do. Find some x values, plug in a y value, maybe find an intersect, maybe find a max or min. But other than that, we can use our calculator all we want. So that's it. That's relations and functions. That's the unit. All right. I already talked about this a bit. Your homework is to study. I'm going to post a review package. I'll post the key to it as well so that you can see how to do things. Send me some questions if you have them, and then complete that summative assignment by midnight on Monday. Alrighty, that is a unit in the books. We are done with relations and functions. Go to that review package, get some studying. Send me some questions in the form. Send me an email. Maybe you set up a last-minute one-on-one appointment so that we can, make sure we're ready to roll before this unit test summative assignment thing, and we'll be ready to roll. Okay, so make sure you get your questions answered, and then make sure to get this thing done. I would do it tomorrow. I would do it on Friday, but at the very latest, it's Monday at midnight, and then we're on to our next unit. Okay, as always, smash the like button, hit subscribe, all of that, and I'll see you guys next week. I guess is when I'll see you.